Okay, in this video we're going to do more practice with the mole concept. So the first question I'm going to ask is which quantity has more atoms? 14 grams of lithium or 14 grams of nitrogen. Okay? Now, the way to answer this question, if you understand the mole, is literally just to look at the periodic table. And we see when we look at lithium that its molar mass is 6.94. And when we compare that to the molar mass of nitrogen, we see its molar mass is 14.01. Now, remember that molar mass is in units of grams per mole. And as I've said in previous videos, the mole is a grouping. All right? It's a grouping that is equal to 6 times 10 to the 23rd particles. So we can, just to make life easy, I'm going to say that lithium is about 7 grams per mole in terms of its molar mass. And we're going to say that nitrogen is about 14 grams per mole. So coming back to the question at hand, we want to know which of the two quantities here has more particles in it. Well, 14 grams of lithium is approximately twice its molar mass. So the answer is the lithium does. Okay? Now, we can apply this same idea to molecules. So let's take a look at these two molecules, H2O and O2. All right, H2O has a molar mass that's approximately 18. It's like 18.016, but I'm just going to call it 18 in order to keep what we're doing simple here. All right, and the molar mass of O2 is approximately 32. Okay, now, just as a review, how do we arrive at the molar masses? All right, remember that to find the molar mass of a molecule, you determine the atomic masses for the elements that are in the molecule. Those are summed together, taking into account how many times each of those elements appears in a formula. So there's 2 hydrogens in water and there's 1 oxygen. The hydrogens are worth approximately 1 gram per mole, and the oxygen's worth 16. So literally it's 2 plus 16 to give us 18. Oxygen has an atomic mass of 16, and since there's 2 oxygens, 2 times 16 is 32. So let's say that we're asked the following question. All right, we're given 36 grams of water, and we're given 36 grams of oxygen. And we're asked the question, which of the two quantities has got more particles? All right, so you could launch into a mass to mole to molecule calculation if that's what you think you need to do. You know, and if we're going to do that, it would be a 2-step problem. We would divide by the molar mass and then we would multiply by Avogadro's number. But you don't need to do that. You can look at this mass and compare it to the molar mass. Okay? And we see that in the case of these two molecules, in the case of the oxygen, its molar mass is 32, and we've been given 36 grams. So basically, we have what amounts to a little bit more than a mole of oxygen in this case. So there's a little bit more than 6 times 10 to the 23rd particles. So this has got a little bit more it's a little bit more than 6.022 times 10 to the 23rd particles. It's close to a mole. On the other hand, the water literally is twice this value, right? 18 times 2 gives you 36. So this is literally somewhere, this is approximately 2 moles of compound, 2 moles of H2O. So this quantity contains more particles. So this has more than 36 grams of O2. More than 36 grams of O2. So if you understand the mole concept, you should be able to rationalize between mass units of things that you're given based on the molar masses. All right? And being able to rationalize between the masses of these things relative to the grouping requires that you understand really what molar mass is, right? So it's the combination of the concept mass with mole. That's the issue. We have a grouping, which is Avogadro's number, that is tied to mass.